welcome to this explainer. If you've ever stared at dense pathology notes and felt like you were trying to decode an ancient foreign language, you are definitely not alone. Today, we're going to change that. We're going to treat these intricate pathological records exactly like a crime scene investigation. And by the time we wrap up, you'll see exactly how diseases, viruses, and toxins leave highly specific microscopic fingerprints right there on the liver. Okay, let's quickly check out our roadmap for today. We'll start with the pathways of liver infection, move into the anatomy of acute hepatitis, then we'll be zoning in on central necrosis, followed by midzonal and periportal attacks, and finally, we'll cover severe and unusual necrosis. All right, kicking things off with Section 1, Pathways of Liver Infection, or as I like to call it, the breach. So to really understand how the liver is attacked, we first need to identify the exact gates the invaders use to breach the fortress. These 5 pathways basically serve as superhighways for our microscopic culprits. For instance, ingested organisms and toxins, they often travel straight up the portal vein to start their assault. But that's not the only way in. Emboli or bacteremia can just ride right in on the hepatic artery. You've also got the umbilical vein, where contamination can happen, the bile ducts, which practically invite infection if they get obstructed, and direct extension, which we see in cases of traumatic reticulitis. It's an incredibly connected organ, which unfortunately means it has multiple vulnerabilities. Moving right along to Section 2, Anatomy of Acute Hepatitis. Let's define the threat. Now, the absolutely crucial point here is defining what we actually mean when we talk about acute toxic hepatitis. Notice the distinction we're making. It's characterized by necrosis, which is cell death, but specifically necrosis that is preceded by degenerative changes, meaning before the liver cells actually die, they go through a very specific, observable sequence of degeneration. It's a gradual, step-by-step breaking down of the cellular defenses long before total collapse. And how exactly do we track this collapse? Well, pathologists classify this destruction strictly by its anatomical neighborhood within the liver lobule. We're talking focal, centrolobular, midzonal, periportal, diffuse, and pericentral necrosis. This list right here gives us a perfect geographical map of the crime scene. Knowing exactly where the damage is located tells us a huge amount about what caused it in the first place. Let's look at the first one on that map. Focal necrosis. If the attack is totally scattered and random, that's what we call focal. You'll see numerous small necrotic areas scattered all across the liver tissue. This is usually caused by things like obstruction, bacteria, viruses, or even parasitic migration, literally leaving a physical trail through the organ. Luckily, the aftermath of this isn't usually severe, and the healed lesions just show minor scarring, without compromising the whole organ. Section 3, Zoning In. Let's talk about central necrosis. Now, if we look at the original source notes detailing centrolobular and midzonal necrosis, you can see how incredibly specific the text gets. It points out that the cells specifically near the central vein are the ones taking the hit here, often wiped out by anoxia, which is a lack of oxygen, or toxins like carbon tetrachloride. Macroscopically, this central destruction leaves a very distinct visual signature. The liver actually becomes enlarged and pale, or in more severe cases, it turns this darker red where the lobular markings become highly exaggerated. Under the microscope, it's a pretty fascinating scene. The cells right around the central vein completely disappear, while the periphery areas of the lobule only show those earlier degenerative changes and some infiltration by protective leukocytes. But here is where the timing of the assault really matters. While a single hit to this central zone is relatively insignificant and the liver can absolutely bounce back, repeated strikes are a totally different story. Repeated attacks lay down a devastating microscopic fingerprint, resulting in permanent fibrosis and atrophy. The organ literally begins to permanently scar and shrink over time. Moving outward, we hit Section 4, midzonal and periportal attacks. What's really fascinating here is how we can literally match the specific poison or virus to the exact neighborhood of the liver it prefers to destroy. Centrolobular hits the center. Midzonal targets the area midway between the central vein and the periphery. We actually see this a lot in humans due to yellow fever. Then you have periportal necrosis, right adjoining the portal tract. This is the absolute hallmark of phosphorus poisoning, where toxins conveyed directly through the portal vein strike the very first cells they meet. And then there's pericentral necrosis. If you're looking at a strange, wedge-shaped path of destruction strictly on one side of the central vein extending up to the periphery, well, Your forensic investigation should immediately point towards Rift Valley fever or uremic conditions. It's this highly specific, asymmetrical pattern of cell death that acts like a flashing neon sign for these specific diseases. Finally, we reach Section 5, Severe and Unusual Necrosis. This is total war. Whole parenchyma is dead, no regeneration. That chilling description from our source notes defines massive necrosis, which is also known as acute yellow atrophy. We are not talking about a targeted regional strike anymore. This is a catastrophic situation where the entire functional tissue of the liver is completely 100% wiped out. When you review the stark, handwritten pathology notes on this, you see the specifics of the diet and poisons that trigger this massive, unrecoverable state. The records detail massive fatty change and the total necrosis of the hepatocytes. It's pretty grim stuff. Whether it's triggered by severe dietary issues or massive doses of poisons like carbon tetrachloride or phosphorus, the macroscopic result is severe. The liver becomes yellow and notably smaller. Because a whole parenchyma is dead, the body just can't rebuild. The organ is left with unyielding post-necrotic scarring, which ultimately leads to inflammation and cirrhosis. It is a biological point of no return. But perhaps the most surprising finding in these records has a really mundane name: sawdust liver. Here, foci of necrosis appear just like sawdust sprinkled onto the liver to the naked eye. What's wild is that this is typically observed in perfectly well-fed young cattle during post-mortem examinations. The irritation is borne by portal veins carrying something in from the gut, causing multinecrotic spots and an infiltration of inflammatory neutrophils. But here's the crazy part. The animal manifests absolutely zero symptoms while alive. You've got a perfectly healthy-looking cow harboring a secretly dotted necrotic liver, which really leaves us with a critical question to ponder. Once this microscopic war ends, and unyielding post-necrotic scarring completely takes over the landscape, how exactly does the body compensate for a radically transformed liver? Understanding these precise pathological fingerprints is just the very first step in unlocking the deeper mysteries of the body's resilience. Thank you so much for joining me on this explainer, and keep questioning what you see under the microscope.